All right, let's dive in. Today, we're going to talk about something pretty incredible, the journey of how our devices all started talking to each other. We're going to trace this story all the way from a single, lonely machine sending a status update to the huge, interconnected smart cities that are being built right now. It's going to be a wild ride.
So let me start with a question for you. What could a simple vending machine and a whole smart city possibly have in common? Now I know, it sounds like a trick question, right? But the answer actually tells the entire story of how modern technology evolved. It's the story of going from just one machine talking to another to a world where basically everything can communicate. And for anyone studying engineering, this story is, well, it's kind of essential.
Okay, so let's rewind the clock, way back. Before the internet was in every pocket and every home, we had a much simpler but really fundamental problem to solve. How do you get one machine to report what's going on with it to another machine without a human having to go and physically check? This was the real challenge that led to the birth of machine-to-machine communication.
You can think of M2M as a super simple, direct conversation. The best way to picture it? A walkie-talkie. It's a point-to-point connection. One device, say that vending machine, calls up a central server and just says, "Hey, I'm out of snacks over here." That's it. A simple, closed conversation designed for one very specific job.
And you've seen this in action, probably without even realizing it. It became the invisible backbone of so many systems we just take for granted. You go to an ATM and it checks with the bank before spitting out cash? Yep, that's M2M. A sensor in a field reporting back on soil moisture? That's M2M too. It was this crucial first step that started automating all these simple tasks by taking people out of the loop.
So M2M was awesome for these one-on-one chats. But you know how engineers are. They started thinking bigger, way bigger. They started asking, okay, this is great, but what if it wasn't just a closed conversation? What if everything could talk to everything else over one gigantic open network? And that massive shift in thinking, that was the leap from M2M to what we now call the Internet of Things.
Okay, so this slide right here, this is where it all clicks. This is the core difference. M2M is all about direct hardware-to-hardware communication, often on a private network. But IoT? That's a whole different ballgame. It's built on the public internet. It uses both hardware and software, and it allows tons of users to access the data all at once. It really is the difference between that simple walkie-talkie and a massive global internet forum where anyone can join the conversation.
And honestly, if you want to boil it all down to one simple idea, it's this. M2M walked so IoT could run. M2M proved the concept. It showed the value of devices talking to each other automatically. IoT just took that brilliant idea, plugged it into the internet, and let it absolutely explode.
So what does that actually look like in the real world? The IoT isn't just one machine talking to one server anymore. Oh no. It's this massive, tangled web of physical things. Your smartwatch, your car, your lights at home, all with their own unique identity, all sharing data over the internet to create this one huge intelligent network. But of course, with all this incredible new power came an equally massive new problem. The dream was this seamless world where any device could instantly talk to any other device. The reality? Well, the reality turned out to be a little bit messier. This was the big uh-oh moment for the pioneers of IoT.
And here's the problem in a nutshell. We got so excited about connecting everything that we kind of forgot to make sure they could all speak the same language. Every manufacturer, every type of software, every platform, they were all speaking their own private dialect. We basically built a digital Tower of Babel, where billions of devices were all shouting at once, but nobody could really understand each other.
Now, there's a fancy word for this huge challenge: interoperability. And it's not just about being able to send data back and forth. No, it's about making sure that data can be correctly understood and acted on. This is, without a doubt, the single biggest hurdle that engineers today are trying to solve in the world of IoT. And just look at the scale of this mess. It's not just one thing. You've got different wireless protocols, different programming languages, operating systems, databases, the list goes on and on. It's like trying to hold a meeting at the United Nations, but every single person speaks a different language and you have 0 translators. It's chaos. How do you get anything done?
But here's the cool part. For an engineer, a problem this massive isn't a roadblock. It's an invitation. It's a huge opportunity. The whole challenge of interoperability, that's the cutting edge. The goal now is to build a kind of universal translator for the Internet of Things. And luckily, the path to get there is actually pretty logical.
So how do you even begin to tackle something this big?
Well, thankfully, we can break it down into a pretty logical three-step path. First, you have to be able to find the device. Second, you have to agree on the grammar of the conversation. And third, and this is the hardest one of all, you have to agree on the actual meaning of the words.
All right, step one. It's all about identity and discovery. I mean, before two devices can talk, you got to be able to find them, right? It's like a universal phone book. Every single device needs a unique address, like an IP address or something similar, so you can find it on the network. Simple as that. You can't talk to something if you can't find it. Okay, next up, step two, syntactic interoperability. This is all about agreeing on the grammar of the conversation. It's about the structure. If one device sends its data looking one way and the other device is expecting it to look totally different, they won't get anywhere, even if the numbers are the same. This is where you need common formats or special software that acts like a translator in the middle.
And that brings us to the final and by far the trickiest part, semantic interoperability. This is the really deep challenge. This is about agreeing on the meaning. If my thermostat sends your system the number 22, does that mean 22 degrees Celsius or Fahrenheit? Is it the current temperature or the temperature I want it to be? Without that shared context, that shared data dictionary, real intelligent communication is just impossible. This is the holy grail.
And that really brings us full circle. The whole journey from that simple vending machine to the sprawling smart city has led to this one massive question. As billions and billions more devices come online, the need for this universal translator, this common dictionary for everything, is more critical than ever. The people who solve this problem won't just be writing code, they'll literally be writing the language of our future. The only question left is, will you be one of them?